And he had phrases that antimatter doesn't produce radiation, it's pollution-free, it's ultimately wonderful, it just kills the enemy without causing any other problems, Wow, isn't this marvellous stuff if you're a military person? Then, of course, the reporters, having got hold of this, wanted to interview the man, and this interview was going to take place. And then the interview was stopped. The Pentagon stepped in and said, "We have nothing to say on this matter." Now, at this point, of course, the conspiracy theorists go into overdrive. This proves that there is something to hide here. Well, I investigated this, and in the course of it, I found on the web that it is possible to dig around and find copies of the actual transparencies, the overheads, the PowerPoint presentation that this man gave. And the URL is in my book, so you can go and look at it for yourself, unless it's been pulled by now, which probably it will be, who knows. And in the course of doing this, I discovered that he mentioned a name of a scientist that I know. In fact, it was a scientist working in those days at Penn State University who had been doing work with antimatter at CERN in the 1990s when I'd been on the committee looking at the experiments. So I contacted him to find out what was going on, and, well, to cut a long story short, the man giving this talk wasn't really running antimatter at all. He happened to be the man who signed the checks for funding research lines. I mean, many scientists, quite genuinely, you get your funding from the Research Council, the Department of Energy, and US Air Force or other places like that. The particular line of research that they were doing was in part being funded by the US Air Force, and in that sense, there was an interest in antimatter. But the idea that the US Air Force were actually seriously looking into antimatter as a source of weaponry or anything was quite beyond the reality. So when the Pentagon said, "We have nothing to say on this," that was actually a statement of literal truth. Now, the question as to, could you, however, imagine making an antimatter bomb? Could you imagine powering a spacecraft? Well, certainly you could imagine it, but in practice, no. So I at least will set your minds at rest. The idea of an antimatter bomb ever being made is, thankfully, science fiction. I'll give you that one without you having to buy the book. But the story of the nonsense that has been propagated out there is a fascinating story. It is, though, the case that research is seriously going on into the possibility that you might be able cleverly to come up with means of creating power sources using positrons. I assess in my book the reason why I am sceptical, but that doesn't mean to say that I'm necessarily right. There's an interesting question here, but I wouldn't recommend investing in that.
And all that said, it's nonetheless the case that there are practical, real-world applications to all this research.
Yes. The practicalities of antimatter are much more common than perhaps one realises. Many people reading the book or listening to this podcast or going to watch the Angels and Demons movie, knowingly or unknowingly, may well have come in contact with antimatter in the medical sphere. If anybody has had a PET scan, that's positron emission tomography, which has saved countless lives and is a wonderful diagnostic tool, is using the power of positrons to annihilate with electrons, and as a result of that annihilation give a signature which the medics can use. I mean, it might sound quite horrible, the idea that you start by ingesting some radioactive substance and then the positrons that it emits destroy electrons in your body and it's all safe. Well, believe me, it actually is, because we're talking here about one or two little annihilations, not talking about big bomb stuff. That positron emission tomography is a well-tested and widely used diagnostic tool. Positrons are also used in testing for metal fatigue, because positron annihilation turns out to be a very sensitive diagnostic tool that can indicate airline turbines, or general turbines beginning to fail far in advance of any other mechanism for showing it up. So antimatter is actually used in medicine, in industry, and of course in science. At CERN, we do use positrons. We make beams of positrons. The answer to my father's question, how do you store the substance that would destroy everything? The answer is you use magnetic bottles. You have a wonderful vacuum so that there's no air for any of the anti-stuff to touch and destroy. You have magnetic fields to trap it in place or steer it and send it where you want to. and you can have a 27-kilometre ring of magnets underground, which is what they had at CERN. Positrons whirl around in one direction, electrons whirl in the other direction, being equal and opposite in charge. They go in the opposite directions under the effect of the force fields. And then you bring them head on, bang, they annihilate. And in a small region of space, for a very brief moment, you're recreating the sort of concentration of energy that the universe as a whole was like within the first billionth of a second after the Big Bang. So by using antiparticles, antimatter, you are able to recreate in the laboratory simulations of the early universe, and from your observation of what happens next, work out how the stuff that we are made of 14 billion years later came to be. And so I find it quite remarkable that groups of atoms clustered together, that's what you and I actually are, have been able to gaze out into the universe and ask questions of the universe and do experiments using antimatter that have been able to show us our origins. I mean, every culture has wondered about where does it all come from. And using antimatter, we are increasingly being able to answer that question and get really to the big, profound question. So for me, as a scientist, antimatter has been the most remarkable tool that we have ever stumbled across.